let me introduce our first speaker for the day. So Dr. Rich Vaia is the Chief Scientist for the Materials and Manufacturing Directorate at the Air Force Research Laboratory. As the Principal Technical Leader for the Directorate, he is responsible for the planning, quality, and impact of the United States Air Force, the United States Space Force, and the Department of the Air Force's Materials and Manufacturing internal and external research and development activities. Dr. Vaia received his PhD from Cornell University in Materials Science and Engineering, separated from the Air Force as a captain in 1999. He's published more than 250 articles on nanomaterials with honors, including membership in the National Academy of Engineering. So with that, Rich, I will turn it over to you. And you're up, there we go.
Yes, can you hear me now?
Yeah, we got you now.
Sorry. First, thank you very much, Mark, Karen, Emma, for putting this together. Very excited to share with everybody online activities that are happening in AFRL, kind of where we're going, and how you, as part of the innovation ecosystem in Ohio, in the United States, can engage and learn more about what we are doing, what we need to do, what we must do for the Department of the Air Force to support the Space Force and the Air Force. I'm going to turn my video off just to save bandwidth, but then pop back on after for questions. So next slide, please. So AFRL is the Department of the Air Force's R&D arm, as I mentioned, supporting both the Air Force and the Space Force. Our moniker is One Lab, Two Services. Although we're headquartered at Wright Pat Air Force Base in Dayton, Ohio, we have facilities across the United States, as shown here, as well as international, in Europe, in Asia, in Tokyo and Melbourne, Australia, as well, and it's in South America. The mission of the laboratory has been fairly constant for over 100 years, beginning with the Army Air Corps establishing an experimental station for aerospace at McCook Field in Dayton in 1917. We have about 6,000, a little over 6,000 military and civilian scientists and engineers working in the laboratories. That's complemented by another 6,000 on-site contractors and collaborators, everything from visiting scientists to postdocs to students. And we execute about $5 billion, about a 1-to-1 ratio of core appropriated funds from Congress and customer money coming through and integrated into our tech development plans. Next slide, please. So the lab's responsible for science and developing, integrating, and risk reducing and demoing new technology for the Department of the Air Force. So what that broad mission spans is everything from fundamental research, which is the purvey of one of our organizations, the Air Force Office of Scientific Research, which is headquartered in Washington, D.C. They extensively invest in academia, from workforce to new innovations that are driven by large problems and large challenges the Air Force and Space Force sees for the future, as well as investing into the in-house programs within the laboratories. About 30% of those resources actually fund bench-level scientists and engineers behind the fence, working also on fundamental problems, so we can collaborate and develop peer partnerships with the innovators in academia, pushing the bleeding edge of the realm of the possible. The other side also spans then taking those innovations and doing applied research and development to integrate, risk reduce, prove out, assess these ideas and understand how they can impact the airman and the guardian in the field, and then do that in partnership with industry to make sure that they are risk reduced and manufacturable. They're prototyped and understand what events they may encounter in service, so that ultimately those concepts and those technologies are available in the U.S. supply chain, so that the acquisition arm of the department can then ultimately integrate, use, buy, and deploy those technologies. The reason I say that is I just want to just put in context that AFRL is part of the broader department's RDT&E appropriations or mission. The laboratory is the incubation arm, the innovation arm, the beginning of the realm of the possible and defining the state of the art. There's also many other parts of the department that works on integration and capability demonstration in the field. For example, AFWorks and SpaceWorks administratively part of AFRL, but operationally their own independent entities, as an example of some of these other parts of the Department of the Air Force's RDT&E machine, where they focus on the rapid integration and development of COTS technology or COTS modified solutions that are then integrated or deployed within a very short period of time. With this mission scope, one of the unique aspects and one of the purposes of AFRL is to be the central point for understanding customer demands across the department. So what MAGCOMs need, what the COCOMs need, what the program offices need in acquisition, what the Department of Air Force's futures groups needs, as well as assessing and understanding the larger S&T ecosystem. Our scientists and engineers are really at the center of bringing together all this opportunity space and all the demand signals to really try to piece out what are those key, pervasive, innovative technologies and investments that need to be made to ensure we maintain technological superiority for the Air and Space Force. Next slide. So where does the strategic drivers come from? This list here shows a variety of documents that, in essence, reflect a shift over the last 5 years from a focus on the global war on terror to a focus on the global strategic competitors and competition that now dominates international engagements. This strategic competition includes science, technology, talent, supply chains, access to critical materials and manufacturing, innovation engines, and others, as well as the need to maintain air and space technological superiority. I would highly encourage anybody who is interested in engaging with the department to have a look at these documents, especially ones on the top. These are the starting point for understanding and engaging and partnering with AFRL. The operational imperatives just was released by Secretary Kendall as guidance to the department, setting the capabilities that are required within the next 5 years. These also set the large R&D vectors for AFRL to help us prioritize and balance our future tech investments. So again, a good place to understand where the department and AFRL is coming from as you engage with possible partners in the laboratory. Next slide, please, or next build. What all this sort of boils down to is in the upper right corner is where the laboratory is focused on what we call functional technology enablers. These are the key pervasive technologies that we feel need step function, new S-curve innovations to ensure we maintain parity in the new global competition. Next slide. So that's good, but our nation's S&T ecosystem is not dominant anymore, and no service is an island. Our national defense requires joint forces, not the independent deployment of different services. And so we cannot operate as we've done in the past and expect to maintain technological superiority for all the reasons I think we are very familiar with. Next slide. So not only do we have to discover and develop new technology to meet mission needs, but we need to do it faster. And at the historic pace of taking 20, 30 years to design and develop and acquire and manufacture new systems, such approaches will not deliver the platforms we need. They deliver platforms to our airmen and guardian that are based on 10 to 20-year-old technology. So AFRL, we are focused on accelerating the science, defining new states of the possible for the technology, validating, manufacturing, and ensuring the state-of-the-art is available in the supply chain, both through research, which is knowledge generation, and through development, which is demonstrating practice and utility. These are all different activities, and what the Air Force Research Lab's primary mission is being able to integrate all these for the department to ensure the seamless acceleration of opportunity through achievable, manufacturable, sustainable, and acquirable technology in the U.S. supply chain. Next slide. So here are ways to partner with our 12,000 S&Es. We do not have all the answers, and so we must interface. And those who are interested in learning more, I highly recommend going to airforceresearchlab.com as a website. This is our front door. It'll provide you initial access to understand all the different ways to engage with the department. Whether you're in academia, through the Air Force Office of Scientific Research, grants, some of the public-private partnerships that are out there, as well as workforce activities to small businesses and engaging with our tech accelerators or licensing IP that the laboratory has developed to open innovation challenges and novel ways to learn about our problems and engage with other teams of industry to solve. Many ways government users can engage across the federal government and the state government, as well as industry. And these are many more ways than the traditional BAAs or requests for proposals. My recommendation and what I have seen over my career that works best is to reach out to the AFRL S&Es, understand, develop a relationship with them, understand the mission focus, and that'll better allow an alignment of what the challenges are and where the investment opportunities are than simply reading the public BAAs many times. So the engagement begins with the partnership, and all these approaches in airforceresearchlab.com provides ways to engage with those 12,000 individuals that work in the laboratory. Next slide. So one of the things I wanted to, talk a little bit more about and emphasize this idea of partnership, the fact that the beginning of us continuing to innovate and solve problems is establishing these relationships at the scientist and engineer level, both in the government as well as in academia and industry, is through public-private partnerships. This is a novel mechanism that the federal government has that allows the establishment of a joint entity that is jointly run and operated by the government and private entities to achieve joint missions and bring together joint needs, and then invest and manage the investment based on those joint needs. Some of the outcomes for these include road mapping, getting the ecosystem on the same page with priorities and needs, establishing these collaboration networks, establishing resources, and creating markets where stakeholders and innovators can bring together. A lot of this is pre-competitive risk reduction, which raises everybody's opportunity to innovate, enables workforce development, not just in K through 12, undergrad and grad, but professional and certifications, as well as probably just as important to all the above is insight into the DoD and developing national validated databases, commercialization and modeling tools and standards. Next slide. Some examples of these public-private partnerships, they can take on many forms. They can be virtual, such as the Materials Affordability Initiative, which has many members tiered throughout the supply chain, from the metal suppliers to the manufacturers to the integrators, working over many, many years to create a single voice and understand how to rapidly integrate new ideas through to design and deployment. The manufacturing institutes are another example of those. This is a combination of a physical hub and a very large virtual member set. These are pre-competitive. They establish an ecosystem that did not exist before, such as additive manufacturing and America Makes, flexible electronics from NextFlex, and for example, advanced robotics and Biomade, which are two new ones. These are great areas to get involved, to not only engage directly with scientists and engineers across AFRL and honestly the entire Department of Defense, but also all types of companies and innovators working in this space. And finally, one of the new ones is like this physical regional network. So the Air Force Midwest Regional Network and Hub, as well as the Mid-Atlantic Regional Network and Hub. Both of these are an attempt to bring together expertise and facilities across a region so that problems and technologies can be rapidly developed through sharing knowledge, sharing facilities, and sharing capabilities. A lot of parallels with some of the very recent announcements from NSF, such as NSF Engines and the Microelectronics Commons. Both of them have many facets that were originally put forward here in the regional hubs. Next slide. And I'll just finally wrap up here with some of the benefits of these to the members. I touched on these a little bit in the beginning, but really it allows information and information sharing, relationships that would not necessarily happen outside of joining one of these public-private partnerships, and having a voice at the table to help craft and prioritize the technological agenda. We believe this is critically important for us to accelerate. In the past, the department would prioritize things, send out RFPs, and that would be the agenda. This is our one of our ways of engaging with the community and jointly developing those technological agendas to accelerate the technologies that we need as well as what the market needs. Next slide. One example of an emerging potential for a public-private partnership is actually right here in Ohio, outside the outside Wright-Patterson Air Force Base. I think as many of you guys are familiar, as Apex and Parallax and the Ohio Aerospace Consortium have mentioned time and time again, Ohio is a great opportunity, one that compares very well with other innovation ecosystems across the United States. And some of the statistics are there down at the bottom, thanks to some great work Parallax did. Within a 4-hour drive of Dayton, that opportunity space is the same or greater than places like Austin, Huntsville, and Raleigh, and in some degrees is a competitor to what is seen in the Valley or in the Boston area. So to capitalize on this, next slide. The base, as well as the Air Force Research Lab, AFIT, and a whole variety of external partners have been speaking and discussing this idea of a hilltop campus around Area B, so part of Wright-Patterson Air Force Base. There was an enhanced use lease offering, which effectively allows a developer to come in and develop part of the land that is at Wright-Pat. And this idea and the land located right next to all the Air Force research facilities at Wright-Patterson Air Force Base and approximately 3,000 scientists and engineers is really this great opportunity to try to remove the barriers between siloed disciplines, both within the laboratory and with the ecosystem outside, and really demonstrate convergence and rapidly bringing together opportunities in microelectronics, nanotechnology, biotechnology, space components, many of the things that Mark mentioned in the OFRIN calls. Some of the terminology that is used around this is about the Aerospace Research Convergence Center. So be on the lookout for that. If you hear about it, if you want more information about it, definitely reach out to the folks at Parallax. Finally, next slide. So as a summary, hopefully I've provided an overview of the Air Force Research Lab, who we are, where our motivation is derived from, and how we set our priorities. There are many technologies that are needed to support both the Air and Space Force. And so there is no simple 1 to 10 list that we can provide. But as I mentioned, the best way to engage is to meet the S&Es through conferences, through collider events, through dialogue days, through ecosystem memberships. It is all about the collisions. It is all about creating those relationships. And through that, understanding where the partnerships are and where the needs are to partner with the folks behind the fence to develop the technology. For academic colleagues on the call, I have provided a handout that the Parallax team will send out and you'll have access to, that specifically lays out many opportunities to engage with the laboratory, to find short-term opportunities to actually work in the lab, to meet people, and to develop those long-lasting research and development partnerships. That handout will be available and has a dozen or so opportunities. So again, I want to thank you guys very much for your attention. I'm looking forward to the Q&A after our next talk. Thank you very much.
Thanks, Rich. Appreciate it.